Java has two main types of exceptions, checked and unchecked. Let's start with some non-code examples. Let's talk about the building of your company. There needs to be an evacuation protocol. Why? Well, because it's not within your control, or the company's control, or whomever's control, that something that requires evacuation can happen. Terrible things like fire, threats and more can happen, and they require evacuation of the building. Evacuation is the backup plan to get out of a terrible situation with minimal damage. So, if there's a plan, this can limit the damage. Hazards like these are so common that most countries require an evacuation protocol being in place. Some other things don't require a protocol or backup plan. For example, think of stairs. So, a step of the stairs can break, and that makes it prone to falling off the stairs. But there doesn't need to be a big pile of pillows under the staircase for when it randomly breaks down. Why not? Well, when we would need that, we could better fix the staircase instead. These sound like two random situations, the building and the stairs. Let me tell you how all this relates to exceptions. We have two kinds of exceptions, checked and unchecked. Checked exceptions are exceptions that the Java compiler requires you to deal with. You have two options for this. Handle the exception with try-catch, or declare the exception in the method signature using the throws keyword. Checked exceptions are like the problem that requires an evacuation protocol. It's out of your control, and you need to have a backup plan in place because it simply can happen. Let me give you a code example. Assume your code is reading a file. An example of an exception that can happen when you try to read a file is the situation that the file you'd like to read is not there. That is not within your full control. The file can be moved or removed by an external program or user. We'll discuss the exact details of exceptions that can happen with files later. Let's first discuss the unchecked exceptions. The compiler doesn't check for those, and they need to be solved by writing better code typically. These are like the staircase and the pillows in that sense. You should not handle these with a throws or a try and catch. That would be like having pillows under the poorly functioning staircase. Instead, you should go ahead and fix the staircase, which in this case would be code. If you feel the need to put a pile of pillows underneath your code, write better code. Examples of checked exceptions are SQL exception and the I/O exception. Both of these deal with external dependencies. I/O is for everything input and output, such as reading and writing files. And SQL deals with databases. The unchecked exceptions include the null pointer exception and the illegal argument exception. Instead of dealing with a null pointer exception, it's better to avoid the null pointer. For example, by working with the optional class, or by checking whether a value is 0. So you may wonder, how do I know whether an exception is checked or unchecked? Some of them are rather logical, but there's a way to know for sure by looking at the code of the exceptions. The checked exceptions don't extend from the runtime exception. The unchecked exceptions do. They happen at runtime. That's why they inherit from the runtime exception, either directly or indirectly. All exceptions extend the exception class. Some of them directly, other indirectly. It's important to understand the difference between checked and unchecked exceptions, as they require different approaches to handling and declaring. Checked exceptions need to be dealt with in the code. You can specify a protocol, or you have a warning for the calling code. Unchecked exceptions usually mean that your code isn't robust and solid enough, and that it needs fixing. That's it for this video on checked and unchecked exceptions in Java. There are two ways of handling them. In the next video, we'll look at how to handle exceptions using the throws keyword.